Alright, the topic of the day, gases. Introduction to thinking about particles of gas, measuring them, and everything associated, which is a lot. Well, I just snipped these pictures off the internet. A couple of odd tidbits. Speaking of helium balloons, do you know that our supply of helium is very limited? Once the Earth is out of helium, we'll never have any more. Unless we send a spaceship to the sun or something that could survive the temperatures and bring some back. Because really it's an unreactive gas and you can't get any more, you can't react anymore, you can't make any more other than a nuclear reactor. I guess that's maybe a possibility if you had a nuclear reactor that could fuse hydrogen into helium. Interesting. Anyways, let me just get to the meat of the matter. How do you measure pressure, air pressure? Have you seen enough evidence in your lifetime to sort of prove to yourself that there is air pressure? Because you really can't see it, you can't feel it because you're born into the situation. But if it weren't there, you certainly would notice it as a lack of pressure. You know, if you drive up into the mountains and a nice Sunday afternoon drive or a hike, sometimes even your ears will pop and adjust. Your eardrums kind of being a gauge or a measure of the air pressure. Yeah, in the olden days, what they used to do is take a big test tube of mercury, and by big I mean like a meter tall. Take a meter tall test tube of mercury, turn it upside down and put it in another bowl of mercury, and the air pressure pushing down on the mercury holds a certain amount of the mercury up into the test tube, and that certain amount at sea level is usually about 760 millimeters. And that's where this number 760 will come. So the distance from here to here, from the bottom to the top, is that since mercury's so heavy and dense, but the air pressure on the outside can hold that mercury up into the test tube to the height of 760 millimeters, 76 centimeters. The amount that the mercury drops down, what would that be? If it was a meter tall, it would be 24 centimeters? Yeah. In any case, that's totally like void. I'm sure there's a few particles of mercury vapor up in that, but there's no air pressure if the test tube is totally full before you tip it over. That's a weird idea. But indeed, now we use different devices, usually electronic devices, to measure air pressure. Where does air pressure come from? Does air weigh anything? And the answer is yeah, it sure does. So if you're at sea level, you got X number of gaseous particles in a liter, creating a pressure, a weight, and all the air above you and around you kind of contribute to that air pressure. You've also noticed, haven't you, diving down in the ocean, there's no air pressure, but there certainly is pressure on your eardrums. Of course, water's 1,000 times more, thousand times more dense than air, so the effect is much more dramatic. But same thing happens if you go from sea level to up into the mountains. You notice the air pressure dropping quickly. As you rise, your ears pop and they try to adjust, equilibrate air pressure inside your eardrum and outside your eardrum. Wow, by the time you're up to, it doesn't give a height, but by the top of Mount Everest, the tallest mountain on Earth, the pressure goes from 100 down to 30. So maybe 1/3 the pressure up on a very, very, very tall mountain. Here's an interesting tidbit. Seems like 1 liter of air weighs about 1 gram, a little bit more. But a liter of water weighs 1 kilogram, so it's 1,000 times more dense. I'm just referring to water because water is the most common density, thought of to remember. So what if, these are the 4 units that are used to measure air pressure, and any of them are good and often used. I guess the PSI, the pounds per square inch, isn't used that much if you're not in the US of A, because no one uses the English system. except for us. So if you're filling your car tire with air and you use an air gauge to measure that pressure, then you know it's in psi. But these are other very legitimate units: atmospheres of pressure, millimeters of mercury, kilopascals. So if I wanted to, oh yeah, so speaking of the mountains, would it be, and all these are equivalent, 1 atmosphere is equal to 760 millimeters of mercury is equal to what we call 101.3 kilopascals, the official metric unit of pressure, or 14.7 psi. In any case, what would it be? Would it be more than an atmosphere up in Alta, or more than 14.7 psi? No, more. This is more than 760. It wouldn't be that one either. And a torr and a millimeter of mercury, interestingly and confusingly, are the same. So I could have labeled this 760 torr of mercury, and this is more than 101.3 kilopascals. So all these A through E are certainly more pressure than is typical at sea level. So I'm going to have to go with F. 12, almost 13 psi is less than 14 psi, and our pressure decreases as we go up into the mountains. So speaking of those four standard, they're not all standard, I guess. Well, they are, different circles. Speaking of those four different possible ways to measure pressure, what the units, I should say, are atmospheres. I can change atmospheres to psi by equating 1 atmosphere to 14.7 psi. Put the atmosphere on bottom, see the units cancel, and 14.7 on the top. This one times this one divided by this one gives you this one. Or convert kilopascals to millimeters of mercury. 760 millimeters of mercury equals 101.3 kilopascals. So I put the kilopascals on the bottom and 760 on the top. This on the bottom, this on top. And the kilopascals cancel. 479.5 times 760 divided by 101.3 gives me a messy number. But if I had 3 or 5, shoot, what happened to my sig figs? I had 4 sig figs here. I think it's exactly 760 millimeters of mercury. It's called 1 atmosphere and 101.3. I wish I hadn't lost a sig fig there. Oh well, you get the idea. PSI goes on the bottom, kilopascals go on the top. If I'm trying to convert to kilopascals, you can figure that one out. So there are the units again, and oh yeah, convert 745 millimeters of mercury into atmospheres of pressure. Wouldn't I put, let's see, what goes on the bottom, what goes on the top? So 745 millimeters of mercury times 1 atmosphere divided by 760 millimeters of mercury. I think that would cancel the millimeters of mercury, a little bit less than 1 atmosphere. Same story, similar story, same procedure, similar story, analogous conversion factor. 0.863 atmospheres changed into millimeters of mercury. Let's see, what goes on the bottom, what goes on the top? Oh, there's an old-fashioned tire gauge. Well, it's old-fashioned, but they're still used all over the place, right? There's a spring in here, and as the tire pressure enters into the valve on this end, the spring, the pressure of that air in the tire works against this spring and pushes the gauge out, and you just read it right there as in terms of psi. I think these little things also of course in the other countries have kilopascals or something like that. Oh, answer. You got it. That's easy. Easy cheesy. I think, is that it? My goodness gracious. Well, that's it. So, see you in class. Thanks, guys.